Okay, we are looking at 9.3, which is similar polygons. And yesterday we looked at similar triangles. So this is going to be a fairly quick lesson because you're going to find that there's quite a few similarities between what we did with the triangles and now polygons. First of all, what's a polygon? Yeah, Richard? More than how many sides? More than 3 sides? Yeah. So like a rectangle, is that a polygon?
Yeah.
Yep. A hexagon? Does everybody know how many sides a hexagon has?
6.
6. Good. Yeah, so that poly, this prefix poly means many, so it's many sides. And so basically we're looking to see if these are similar polygons. I want the cell phones gone or I'm going to take them. Thank you. So we want to compare these two figures that are here, and for starters we would want to figure out if these could be considered similar polygons. So here are some of the qualities or traits or properties of similar polygons. Kind of like triangles, the corresponding angles are equal. So that's one of the traits. The corresponding side lengths are proportional. What that means is, just like last day, it means that they have a relationship, the sides do, to one another. So if I tell you that these two are similar, I think I showed you last day that it would have a symbol that looks kind of like this. It's like a half of an equal sign, but it's squiggly. That is an indication that they're similar. So if we know that and we want to figure out what the lengths of the sides are, we want to compare these two, well, by starting out by looking at these, we would want to first of all take a look at the lengths of the sides and try to see like which ones belong with one another, which ones sort of match up. So if I start, let's say, down here, I need to make that thicker so you can see it. But if I look at this side here, I'm going to call that side QP. We often do that to name our sides. I could put another variable there, like call it X or something, but usually we refer to the endpoints, Q and P, and so we call it line segment QP. Which one is that the same as on the other polygon? TUT or TU, yeah. Does that make sense to everybody? When naming them, it doesn't matter. If you said UT, it's fine. If you say TU, that's fine. But we normally try to go in alphabetical order. That's how you'll normally see them written. But not a big deal if you write it the other way. But yeah, there's a starting point. And then we know that QP is 15. And we don't know what TU is, but they've put a variable here called Y. So I'm just going to write that, 15. Well, actually, I'm not going to say equal to, but I'm going to do this to show you which ones match up with which one, right? So, and maybe I shouldn't say equal to, I'm going to do this instead. If we want to use the measurements here, knowing that they're similar polygons, to set up a ratio to determine what the calculations would be, I could set this up to say 15 over y. So I've just chosen this one first and then set it up over y equals, well, I want to look at which other measurements are given to me that match up. So what I mean by that is our measurement here, MN, is equal to 18. Everybody see that? Which of the measurements goes along with that? So that's going to be 18 here. From this, the polygon that we have on the right here, which of the sides matches up with that or belongs? The 30. Everybody good with that? So this line segment SR is the same as the line segment MN. So we're looking to see which properties sort of match. So I could say that this 15 over y is equal to our 18 over 30. So again, just like last day with the similar triangles, We're setting it up as a ratio or as an equation, and then we can use our algebra skills to start to work our way through this. I purposely put the y at the bottom so we can practice our algebra skills, but I have the choice. I could have done y over 15 equals 30 over 18, which probably is the smarter choice. Do you see the reason for that? It just makes it so there's less work for us to do, right? But I want to practice our algebra skills. So we don't like having y at the bottom. How do I bring it to the top? Algebra is all about opposites. So what's the opposite of dividing by y? Yeah, we're going to multiply by y and multiply by y here, which allows us to cancel it, right? So we end up with 15 equals 18y over 30. Everybody good so far? Okay, so then we want to get rid of the 30. The rest of this is just about working on our algebra skills. How do I get rid of the 30 if that's what I have down there? Yeah, multiply by 30 on both sides so we can get rid of it there. And we could have reduced first. It might have been better for us to reduce the 18 and the 30 because simplifying first makes life easier for us. But these are numbers that are pretty reasonable. I'm going to put a 0 at the end, but basically what's 15 times 3 if we just use our mental math skills? 15 plus 15 plus 15, or 15 times 3, what is that? Yeah, so we end up getting 450 equals 18y. Is everybody good so far? Okay, and then we want the y by itself, so what's our next move according to our algebra skills? Yep. Divide by 18. Everybody see that it would be gone. We would be dividing both sides technically by 18. And what do we end up getting when we divide that? Well, looking at these two, we want to find a nice, smart, easy way to simplify things. How can we do that? What jumps out at you? What number goes into both of these? That's going to make our life easier. And it might be different answers for all of you, but life would be easier if we can find a large number that fits into both of them. You could even ignore the 0 for a minute. If you just had 45 and 18, what's a large number that fits into both? 9. So if we do 9, how many times, or what's going to be left at the top if I do 450 divided by 9? 50. And how about at the bottom? 2. Everybody see how we did that? So we divided this by 9 and divided this by 9. That's how we're getting that. And then, so what is our y equal to after all that work? Our y is equal to 25. Good?
That was easy.
And that's literally it. Page 340. I'm going to get you to do number 8. I want you to practice all of those